Hi, everyone. Today we are going to cover our second part of partial fractions. Um, so these are kind of special cases. They're not really special cases. They appear a lot, so I don't want to call them special, but they're different than just having regular factors where we have multiple factors. And they're different. So we're going to look at these, and I just want you to kind of be heads up. I'm going to skip some of the steps that I went through the other day, um, just to make them a little bit shorter and a little bit quicker. But if you have any questions about some of the steps I skipped, feel free to email me. I can send you my notes where I kind of break it down even further. Okay, so let's go ahead and jump in. Example 5 says evaluate the integral of 2x, excuse me, minus 5 over x squared times x plus 1 dx. Okay, I'm doing this in red because I'm going to do it the wrong way, just to show you why this doesn't work. So 2x minus 5 over x squared times x plus 1 equals, sorry guys, a lot of people will say, okay, we have a over x squared plus b over x plus 1. I'm going to go ahead and solve this like I normally would. Again, it's in red because this is wrong. And I get 2x minus 5 equals a times x plus 1 plus b times x squared. So 2x minus 5 equals ax plus 1 plus b x squared. Oh, a times a. Okay, so pretty much 2x minus 5 equals, uh-oh, don't go away yet. There goes. bx squared plus ax plus a. Okay, and if we solve this, again, this is wrong, it's in red. The number in front of x is a, so I get a equals 2. The number alone is a, so a equals negative 5. A cannot equal both of these, so this is wrong. Completely wrong. Okay, so what people often say is, because the x squared is what's getting us. The x plus 1, we get b over x plus 1. That's what we normally accept. But maybe we shouldn't have put the squared there. Okay, so let's go back through here. Uh-oh. Again, I'm going to do this, and it's all going to be wrong. So I'm doing it in red. Sometimes doing things the incorrect way allows us to learn how to do them the correct way. What if we just do squared? How do we solve that? So multiplying this out, we get 2x minus 5 equals, a times x plus 1 plus b times x squared. So 2x minus 5 equals ax squared plus ax plus bx squared. So 2x minus 5 equals x squared, a plus b plus ax. We have, oops. We have nothing for our constants, so plus 0, so I get automatically negative 5 equals 0. That's an issue. So neither one of those ways work. So how can we do this? All right, so I'm going to try and delete all of this wrongness at the same time. and not completely freeze my computer. Okay. So having just an x and having just an x squared in there didn't work. So what we do, key tip, if a factor appears twice, let's say more than once, we need a fraction for all possible powers. Okay, that probably is too mathy. And so what I'm saying here is if I have 2x minus 5 over x squared times x plus 1, I need an I need an x, so a curve for the x, but then I need a b, and then I need an x squared plus c over x plus 1. So for every power of this factor, if it had been 5, I would need a x squared, x cubed, x to the 4th, and x to the 5th. For every power, I need a fraction. Okay. So now that we have this, I'm going to multiply both sides by my denominator. So multiply, oh no. Multiply by x squared. Told you guys, I never leave enough room. And x plus 1. Multiply by x squared and x plus 1. So I get 2x minus 5 equals a times x plus 1 plus b times x plus 1 plus c times x squared. Okay, so multiplying that in. And so we get 2x minus 5 equals ax squared, multiplying this in here, plus ax plus bx plus b plus cx squared. Okay, so now I'm going to rearrange this to make it look like this side. And you're probably asking, well, we have x squareds over here. What are we going to do? And I'll show you in just a second. Actually, I'll show you now. There's really 0 x squareds here. That's all. If something occurs on that right-hand side that's not in that left-hand side, there's 0 of them. So I have 0x squared plus 2x minus 5 equals, I'm going to do all the x squareds, and I'm going to use my highlighter, even though my computer doesn't like me right now. And I have a plus c x squared. And then I'm going to round up all my b's, or all my x's. So I have plus a plus b x, and then everything that's not an x, or an x squared by itself is sad little b plus b. I often tell students, go ahead and bring markers on the test. They'll really help. Now to build our systems of equations. Okay, so I have a plus c equals 0, a plus b equals 2, and b equals negative 5. Okay, so I already have b, So I know a plus b equals 2. So a minus 5 equals 2. So a equals 7. And then I also have a plus c equals 0. A is 7. So 7 plus c is 0. So c equals negative 7. Okay. So my long equation, the integral of 2x minus 5 over x squared times x plus 1 dx is equal to the integral of 7 over x plus negative 5 over x squared plus negative 7 over x plus 1 dx. All right, I'm going to rewrite this middle one. I have the integral of 7 over x plus negative 5 over x and negative 2 plus negative 7 over x plus 1 dx. Katie, why in the world did you move only that middle one? Well, this is a linear. Let's highlight what I'm talking about. X is just linear. X plus 1 is a linear term. This x squared was not linear, so it's not going to be an ln. These linear terms, they're just ln's, but that one is not, and I need it in a form that I can integrate. Okay, so this is equal to 7 ln of x plus negative 5 x to negative 1 over negative 1, because we add. My brain almost said negative 2, but negative 3, but negative 2 plus 1 is negative 1, minus 7 ln of x plus 1. These two in blue are linear. There's nothing on the top here, so they are just ln's. And don't forget the most important part, plus c. Okay. So this one is a little special, mainly because of this x squared. Because it changes how we write our factors out. All right. So let's look at our next example. We have 2x squared minus x plus 4 divided by x times x squared plus 1 dx. So first we need to do the partial fraction. Again, I'm going to do this wrong because guaranteed on the test, at least one of you will come up with the wrong answer, and I want you to be able to think about what did Katie do after the wrong answer, because she did it wrong, and this is how I did it, and I know, so let's kind of do it that way. Wrong. 2x squared minus x plus 4 over x times x squared plus 1. Notice we cannot factor this any further. It's an irreducible quadratic. So if I do what my brain tells me to do, which is a over x plus b over x squared plus 1, multiply through, we get 2x squared minus x plus 4 equals a times x squared plus 1 plus b times x. And so I get 2, come on now, 2x squared minus x plus 4 equals ax squared plus a plus bx. Okay, right off the bat, a equals 2, a equals 4. That's an issue. So this is wrong. Okay. So the fix to this and I'm going to erase this too, trying to use red for the wrong one, is when we have 2x squared minus x plus 4 over x times x squared plus 1, is we have a over x is a given. Plus, what we need is, because notice that this is a linear term and on top it's just a constant. Well, when we have an irreducible quadratic, what we want to do is give it two sets like we did before. We had an x squared in the bottom, so we had an x and then we had an x squared. But we can't, this whole factor isn't squared. But we want to kind of give it an extra piece. So we can do that on top. So we'll have bx over x squared plus 1 plus c over x squared plus 1. This is the fix. It's not very fun. It's not very pretty, but this is the fix. It gives us a linear term to work with. So I am going to multiply both sides. Again, did not give myself extra room. One of these days I will. X times x squared plus 1 on both sides. X times x squared plus 1 on both sides. And so we get 2x squared minus x plus 4 equals a times x squared plus 1 plus bx times x. So bx, that term, times the x that's left over, plus c times x. Okay. Just a side note, if you're asking where some of my terms went, both of these terms get factored into each of these. And so a times x times x squared plus 1, the x's will cancel, and I'm left with x squared plus 1. bx times x plus x squared plus 1, the x squared plus 1 on top and the x squared plus 1 on bottom cancel. c times x squared plus 1 divided by x squared plus 1, the x squared plus 1's canceled. In my first lesson, so part 1 of partial fractions, I wrote this part out so that you can see it. So feel free to go back. I just don't want to completely run out of space for this. Okay. So solving this, I want it to look like something x squared minus x, something times x plus something. So I got to rearrange that right-hand side. So I have 2x squared minus x plus 4 equals. I'm going to multiply this out and rearrange it after that. So I have ax squared plus a plus b x squared plus cx. All right, rearranging these, 2x squared minus x plus 4. Guys, on test, I would suggest having colored pencils. So I have my squareds, my x's, and then a frozen computer, and then my constants. Okay. So I will have a plus b x squared plus c x times x plus a. Then I'm going to write my systems of equations. So the number in front of x squared is 2. So I have a plus b equals 2. C equals -1. And then a equals 4. All right, the only thing I don't have is my b. So I'm going to use this equation right here, this equation 1. And I have 4. Let me rewrite the equation so we know what we're talking about here. We have a plus b equals 2. My a equals 4. So 4 plus b equals 2. So subtract the 4 on both sides. Don't judge me. 2 minus 4 is -2. So b equals -2. Okay. So putting all this together, we have the integral of 2x squared minus x plus 4 over x times x squared plus 1 dx is equal to the integral of 4 over x plus -2x over x squared plus 1 plus -1 over x squared plus 1 dx. Okay, these are a little trickier to integrate. First, this one's a linear term. This is going to be ln. This one might easy peasy. However, this one right here has an x squared in the bottom and a linear term up top. We got to try u substitution. This third guy has an x squared plus 1 in the bottom and a constant on top. Your brain should be saying inverse tan. So each of these integrate differently. So we are going to go step by step for this because I want to kind of show you guys how they work. So this first one, this yellow one, we get 4 ln of x. Okay. Plus the integral of -2x over x squared plus 1 dx plus the integral, and I'm going to bring that -1 out. I'm going to do minus. Whatever number that had been up there, I would have just brought it out. So -1 over x squared plus 1 dx. Now these can be a little bit more complicated. So it could have been 9x squared plus 4. And we would have had to do a little bit more work like we did in u substitutions. So this one's easy by design, but they can be tricky. Okay, so I'm going to go off to the side. Just way off to the side. I'm going to do some scratch work. And we are going to do the integral. Sorry, I've forgotten it. Of -2x over x squared plus 1. -2x over x squared plus 1 dx. My u is going to be x squared plus 1. Du over dx is 2x. And I'm doing this quickly because I'm assuming by now you're really, really good at u substitution. So du over 2x is equal to dx. Whoa. Integral. -2x over u du over 2x. 2x is canceled. There's still -1 left, so -1 integral of 1 over u du. So we do have an ln. However, we have some constants left over, so we have -1 ln of u plus c And so -1 ln of x squared plus 1. I suggest you working this out off to the side because sometimes the constants work out a little funky. It just really depends on what's going on in the bottom and what constants you have on top. I just suggest working it out. Okay, so we have 4. Come on now. ln of x plus. We said that was negative ln of x squared plus 1. And this one, right here, this should be screaming at you, that's inverse tangent. So I get -1 from here. Now this piece is inverse tan, so tan inverse of x, and we're done, plus c. So this is my purple integral. And this is my blue integral. And this was my yellow integral. My computer is running very slow. All right. So the distinguishing factors between the two of these, this one's a linear term. Top has no x's in it. This one's a quadratic, and there's an x in the top. Use substitution. Try it. If not, it's partial fractions and we did something wrong. Over here, x squared's in the bottom and a constant in the top. Screams tangent, inverse tan. All right. We are done. I'm going to zoom out just a hair. So a long problem, but we definitely did it. I also want to mention, guys, if you are on a test, at least for me, you're on a test and you're solving and you're like, you get the initial setup and you're just like, I'm solving and I'm not getting numbers that are right. I'm getting zeros. I'm just getting things that don't look right. And when I plug them back in, things don't add up. Just make up numbers. Just make up numbers and go with it because at least I can see that you're integrating them correctly. So there's 2 parts to this problem, or I guess 3 parts of this problem when I'm grading I'm looking for. 1, your setup. Is your initial fraction equal to the correct setup? And then are you solving the systems correctly? Do you get a system? Are you solving it? And then the third thing, are you setting your integral up and then solving your integral correctly? So those are the 3 major subsections I'm looking for when I'm grading this test. Other teachers, if you're looking at this for some other teacher, they may grade differently, but that's just me. All right. So let's keep on. Example 8. Now this problem's kind of long. I hope I gave myself, yes, I gave myself 2 pages. Good. So first thing I want you to notice is that the numerator power, the power in the numerator is a 3, power in the denominator is a 2. All of these other ones, here the highest power, if I multiply this out, would be a 3, top would be a 2. Here, multiplied it out, would have been a 3, top one would have been a 1. Here, multiplied it out, 2, 1. So up until this point, my power in the denominator, the leading term power, has been greater, the denominator power has been larger than the bottom. Than the top. Hold on. What am I talking about here? I'm going to use the excuse that I had a pretty bad fall last week and I have a concussion, so That's my excuse. And now my computer's frozen on something that's wrong. So we want I'm going to erase denominator. I'm going to do bottom power is greater than the top power. So denominator power is greater than the numerator power. In this one, it's not. So what we need to do, we need to do some work before we can actually do partial fractions on this. So if, then use partial fractions. Else, so if not, we need to use long division. So I'm going to bring us back to some algebra, and we're going to use some long division. So let's do, I think I need to update my computer. This is very frustrating. Okay. We're almost done. This is our second to last page. So if we had 6 divided by 124, we know that this is really, if I was doing long division, 6 into 1024. And I would say, okay, does 6 go into 1? No. So does 6 go into 10? Yes, it goes into it 1 time. You have 6. 10 minus 6 is 4, and then I drop down my 2. And then say, how many times does 6 go into 42? 7 times. 7 times 6 is 42. Subtract them, and I get 0, and I bring down my 4. 6 does not go into 4, so 0 times. I'm left with 4, so I have a remainder of 4. So I wrote that initial one completely wrong. 1024 divided by 6. There we go. And so we get is 1024 divided by 6 is really 170 plus 4 over 6. Going back to our algebra days, and I'm sorry I wrote that wrong, but now it's corrected. Everything's good. Okay, so we are going to use long division on this. All right, and I'm going to come over here, set this up. Okay, so we had 4x cubed plus 8x plus 16 divided by x squared plus x. So really, this is x squared plus x and 4x cubed plus 8x plus 16. Now, I find long division with functions actually a lot easier than I did find long division with numbers. Okay, so what we need to ask ourselves, what can I multiply x squared to in order to get 4x cubed? Well, if I multiply it by 4, I get 4x squared, and I need 4x cubed here. So I need an extra x in there. So 4x. So 4x times x squared gives me 4x cubed, but I have to multiply it by both functions. So 4x times x gives me 4x squared. Okay, and what I'm going to do, exactly what I did over here, subtract them. So 4x cubed minus 4x cubed is 0. There is no x squared, so what I tend to do is I write it in. plus 0x² plus 8x plus 16. It just makes life a little bit easier. So I'm going to subtract that, and I get negative 4x². Okay, then I bring down the next term, so plus 8x. I'm just going to bring it all down, plus 16. So what times x² gives me negative 4x²? Well, I'm going to say negative 4. So negative 4 times x² gives me negative 4x². Negative 4 times x gives me negative 4x. All right. Now I'm going to subtract these. Negative 4 minus negative 4 gives me 0. 8 minus negative 4, remember negative, negative, flip it. Feel free to use your handy-dandy calculator. 8 minus negative 4 gives me 12. So I have 12x plus 16. Now then I ask myself, what times x² gives me 12x? Well, there are less x's in 12x plus 16 than there are x², so we're done. So we have a remainder of 12x plus 16. Okay. So I'm going to go to my next page because I am out of space here. And so what I have is 4x³ plus 8x plus 16 over x² plus x is equal to 4x minus 4 plus 12x plus 16 over x² plus x. Now, looking at this, I know how to integrate 4x. I know how to integrate 4. This one is going to require some work. All right. So let's focus on the piece that requires some work. Okay, so we need to expand 12x plus 16 over, let me go ahead and factor this. This is just x times x plus 1. They both have an x in them. X comes out, and that's x plus 1. Okay. So let's go ahead and expand that. So I have 12x plus 16 over x times x plus 1. And this equals a over x plus b over x plus 1. So I have 12x plus 16 equals a times x plus 1 plus b times x. And I get 12x plus 16 equals a x plus a plus bx. And now I want it to look like something in front of an x plus something without any x's in it. So we get 12x plus 16 equals a plus b x plus a. This is where I get my systems of equations from. I get 12 is a plus b, and 16 is just a. So we have 12 equals a plus b, and 16 equals a. Okay, so let's go over here and solve for b. So I have 12 equals a plus b, but we know a is 16. So 12 equals 16 plus b. I'm going to subtract 16 from both sides. Guys, I'm just going to use my calculator. 12 minus 16. Negative 4. So b is negative 4. All right. So, therefore, the integral of 4x cubed plus 8x plus 16 over x squared plus x. I want to make sure that's 16. Yes. Equals 'There it goes. Equals 4x, the integral, dx, 4x minus 4. Just making sure we got all my steps right. Plus, our a is 16. So 16 over x plus negative 4 over x plus 1 dx. And I'm doing this without looking at everything, and I want to make sure my memory is right. So 4x minus 4. A is 16. B is negative 4. Okay. So this is 4x squared over 2 minus 4x. This is an ln because there's no x on top. This is linear on the bottom. Plus 16 ln of x plus negative 4. The bottom is linear. Nothing on the top. So 4 ln of x plus 1 plus c. And we are done. That is a very long problem. Okay, so I'm going to zoom out and we're going to talk through it. Okay. So the first thing we had to do is long division. And we did long division because the bottom, the numerator, the top, the power, the leading term power is the highest, is higher, is bigger than the denominator, the bottom. So we had a 3 on top and a 2 on bottom. That means we have to do long division. Long division over here. Ask ourselves, what times x squared gives me 4x cubed? And we simplify this all the way down. Okay, so once we do long division, we got 4x minus 4 were the remainder of 12x plus 16. Okay, just making sure. So here, we know we can integrate the 4x. We know we can integrate the 4. What we can't integrate is that 12x plus 16. So we need to expand it using partial fractions. We factor the bottom. We write a fraction for every factor in the denominator that we have, ax plus bx plus 1. Set up our systems of equations. A plus b equals 12, a equals 16, b equals 4. So then we have to write out our equation. So the integral up here of 4x cubed plus 8x plus 16 divided by x squared plus x equals the integral of 4x minus 4 plus 16 divided by x plus negative 4 over x plus 1 dx. And then each of these is kind of nice to integrate. This problem can get really messy because we could get one of these and combined with something like this where a tan inverse. You just never know. It can happen. Okay. So there's three kind of special cases that I want to talk about before we move on. The first one is if you have a power or a factor that's being squared or cubed or something like that, you need a fraction for every power that it has. Then you could have a quadratic that's irreducible, like we cannot factor this at all. And in that case, we need a linear term and we need a constant term. So bx plus c to compensate, and so we can solve this equation and rewrite it as a function of three fractions. And then the last one is when the power on top is bigger than the power on the bottom. And that we need to use partial fractions. Sometimes you have to use multiple of these techniques to solve, and that's okay. It happens. All right, our last page here says identify the best method for solving each integral. I will say these are always on my test. And write the first step to solve the given integral in the space below. You do not need to solve the integral. Each choice may be used more than once. Okay, so our choices is just to simplify. Use a U substitution, integration by parts. We have a partial fractions. We have long division. We have the Pythagorean identity and the half angle identity. Just real quick, the Pythagorean identity is when we use that sine squared plus cosine squared equals 1. And it's kind of in combined with a U substitution. But if you have something where you would use this in your problem, this is what I'm looking for. And that half angle identity is where like the sine squared equals, oh gosh, I can't remember if plus or minus 1 plus cosine squared divided by 2 or 1 minus cosine squared divided by 2. I can't remember if it's plus or minus, but it's on your test. So that's your half angle identity. And these other ones we kind of use quite often. Okay. So A, we have the integral of 4x divided by x squared plus 1 dx. Notice we have a squared in the bottom, but we have an x in the top. All right. So this is just x squared plus 1. There's no x in it. So if I took a U substitution and I let U be x squared plus 1, so du over dx is 2x, so du over 2x equals dx. Notice that those would cancel. All my x's would be canceled. So it is definitely U substitution. So this is B, a U sub. And you can kind of quickly do the substitution in your head and see, okay, that would cancel, a 2's left. If you do that in your head and you're like, oh no, there's x's left, try something else. That would then be a partial fractions. Okay, B, we have 4x plus 8 over x squared plus xx plus 9. So you may be thinking, well, let's use substitution work last time. Let's try it again. Let's try it. I'm doing this in red, notice. U equals x squared plus 6x plus 9. Du over dx equals 2x plus 6. Du over 2x plus 6 equals dx. This 2x plus 6 is not 4x plus 8. I cannot make them be the same thing. If I pull out a 4 here, I get x plus 2. If I pull out a 2 here, I get x plus 3. These are not the same factors. U substitution does not work. Well, when U substitution does not work, that means we are going to use partial fractions. So if I factor this is x plus 3, x plus 3. So I get 4x plus 8 over x plus 3 squared. So a over x plus 3 plus b over x plus 3 squared. This is partial fractions. This is, oh, I shouldn't have done this in red. Sorry, guys. I'm going to leave it in red. This is correct. Sorry. Okay. Here, again, U sub. I'll do it just because I know people will say it has to be U sub. Du over 2x equals dx. If I substitute this, so I have the integral of x squared over x squared minus 9 du. Oh, that should have been a u. U over 2x. One x cancels, but I still have an x. That nothing's happening. So we're done. It has to be some form of partial fractions. But wait. Notice that the power in the top, the highest power in the top and the highest power in the bottom are the exact same. That means we have to use long division. So we have x squared minus 9 into x squared. This goes into here one time, and I get x squared minus 9. Subtract them, so I get positive 9. Remainder of 9. So we get x squared over x squared minus 9 is equal to 1 plus 9 over x squared minus 9. And then from there, we have to expand this out and do partial fractions. But I really want the first step. So this, our first step is long division, so E. All right, guys, I know this is a lot to take in. You might have to watch this video a few times, work on the homework. If you have any questions at all, feel free to email me and I'll get back to you soon.